static score from class A and class B. This is a value of their midterm test, and we will see the normality of data is from class A and class B. Okay, to test this normality, input your score to SPSS and make criteria in view variable view like this. And the next, we will test using the analyze, and next we will do this one, explore. Okay, yeah. Nah, this is the before. Now we input the class A and class B data to dependent list like this, and then you must to click the plots, and you click this one, the normality plots of tests. If you want to give a histogram graphic, you can click this one too, and continue, and then display both, and okay. So we have the analysis like this, and you can see this is a graphic of, or the, oh, I'm sorry, this is a table of test of normality. We can see in here that class A, this have the data is significant around the 0,03 and 3, but we can see the data is less than 50, so we will use the spiral width because the Kolmogorov-Smirnov is more accurate if the data is more than 50. And we can see this is a spiral wheel, and the significance of the spiral wheel normality is 0,272 for the class A. So it is mean that if the significant more than 5%, so the data of the class is normal. And then for class B, we can see that significant is just only for 0,019, is around that 1,9%, is less than 5%. So the normality of the data is for class B is not doesn't normal. This is a histogram of the class A and class B. We can see that in class A is dominated by the average of class. The average is around the 84, so this one. And then for class B, the average is 75, but you can see that this class is not very yet, because some students is distribute like the small ability students in this class, and there are some students that have the high ability in this class, so the data of the class B is doesn't normal, is not like the class A. So this is for the example. You just to use this step to test the normality of the data, and you can see the significance of the data. Okay, we back to the PowerPoint, and the last is what's we gonna do if the data is doesn't normal. If we can see in here, some people like suggestion to data manipulation, but I will say that the data manipulation is untechnical and prohibited practice, especially in effort to meet the assumption of the data is normal. There are some alternative if the data is doesn't normal distribute, like we can use the, if we gonna to doing the independent sample t-test, we can use the man widely u test. This is an alternative for independent sample t-test. And then some other alternative we can use to test the statistic of the data if the data is doesn't normal. Okay, just only this one, this alternative. Okay, thank you for so much. We next to the next topic.
I will explain about find homogeneity test with independent sample t-test. This is a Levene test. So in here we have data in class A and class B with the code of class for one for class A and two for class B. So we will put the data to SPSS from class A. And we will put the data of class B in under of class A in one column. Yeah, the code also. But in the different column. Variable view, the decimal is 0. The name is the seal and this for the class. So it's in the value. The value 1 for class A, 2 for class B. Okay. Okay, to find the homogeneity, we've go to analyze, compare means, independent sample t-test. So the hasil, put the test variable, code the class to the grouping variable. Option. Because analysis by analysis, continue and define group 1 to class. Group 1 to 1, the code of class A, and group 2 is 2, the code of class B. Continue. Okay, this is the result of independent sample t-test, and we will focus on the Levene test for equality of variable, and the significant is 0.072, and this is how to analyze the homogeneity with the analysis of with the significance of an homogeneity. Okay, thank you.
Okay, so right now I will explain about the homogeneity test using descriptive statistic methods. So right here, as you can see, we have the great result for mathematics in class A and B, and we have the code for class A and the code for class B. The code for class A is 1 and the code for class B is 2. So what we need to do here when we have this data, we can first take the grade for the class A first. Make sure it's only the grade. We're not gonna be copying these words into our SPSS, and then we paste it in copy SPSS. Wait, yeah, we paste it here. Oh wait, paste it here. Make sure it's in the data view first, and we already copying the data for class A. And what we need to do for data class B is We copy it too, but we place it below the data of class A. So it will look like this. We paste it below it. No need, like we don't need to use some space. You only paste it below, exactly right below it. And then for the code, we also could paste it, but we paste it right at the column beside it, beside the grade. So it's 1, we copy it, and then we paste it here like this. And we do the same as the number 2. Maybe I will copy it right here and then paste it under here. Yeah, we get this. It will be like this. So we have the data for class A and class B, the grade, and then we have the code for both of the class. So we go to into the variable view. So we can, in case we will forget about which is the class or which is the data, which is the class, we can change the name right here. We can change it into grade. It is the grade, right? And then the second is we have the class. So we're not forgetting. And if you feel like annoyed by this decimal number, you can also change it here. The decimals become 0, so you don't have any decimal at all. It will look like this, and then don't forget, because it has the class and the value of class A and class B is different. We have the different code for them. So here in the value, we can change it like this. We change the value 1. We need to use the label so we not forget about them. This is value 1 is for class A. We need to add it, and the value 2 is for class B. Class B. And we have both of these. We can see at the data view. You can change it like this. Here, class A, and then I have class B. And right now for analysis this, we can go to the analyze and then descriptive statistic, and we need to go to the explore. Once we get the explore, in the dependent list, we need to input the grade, and for the factor list, for the class, we input it into the factor list. So it will be like this, and right now, you see the plots right here. So in this plots, we need to make it the power estimation. Okay, when we continue this, it will be like this and display both. And then we click OK and wait. And then later we can get the output. Now the output will be like this. We doesn't need to see the case processing summary or descriptive. We only see the test of homogeneity variance. So as we see here, we can see this, and we need to see the significant value for grade based on mean. So we have the significant value here is 0.072, which is greater than 5%, or 5% is 0.05. Since it is greater, then we can assume that this data is homogeneous. Maybe that's all. Thank you.
Okay, so next I'm Fatia. I'm gonna explain to you how to do the homogeneity test with SPSS, yeah, with the ANOVA menu. So this we have a problem, or we have a data that shows an experiment class and a control class that has a different model, or different learning model. The first one using PBL, and the second one is using conventional model. For the PBL, we got the code is 1, and then the conventional one is 2. The code is 2. Then we want to this is the problems that says a study on the comparison of PBL and conventional learning in influencing students' mathematics learning outcomes. Obtain post-test results as in the following table. Verify whether whether the data is homogeneous or not. So okay, so for using the ANOVA test here, we have the SPSS screen, yeah, SPSS screen that we already input the data here. This is the data for value of PBL score, and then this is for the conventional score. And then in the variable view, we name it with class and nilai, and we explained it with 1 is PBL and 2 is conventional. Now, to test the homogeneity of data, we have to click the analyze and then compare means, and then we will go to the one-way ANOVA menu, and then we take the nilai 1 or the score 1 variable into the independent list, and then the class 1, the class in the factor list. And then we choose options here, and then we check box the homogeneity of variance test in here, and then we continue and okay, click okay. And then we got here, we have the test of homogeneity of variance and ANOVA output. We just want to know whether the data is homogeneous or not. So we can see the table in this one, the test of homogeneity of variance, that shows we can see focus on based on mean, that shows the sick value. The sick value is 0,314. It's greater than 0,05. Then we can conclude that null or H1 or hypothesis null is accepted, then the data is homogeneous, like that.